Hello everyone, welcome to Learn Ladder Logic. Today we are going to complete exercise 1.2. So let's begin. Okay, the first question, prove that root 5 is an irrational number. Okay, so we know that root 5 is an irrational number, but we have to prove it here. So let's do it. Okay, so we'll write, let us assume to the contrary, that root 5 is rational number. We are telling that root 5 is a rational number. Okay, we are just showing them that no, root 5 is not a rational number, it is a rational number. Then what we'll do is root 5 is equal to a by b, because whatever number is a rational number, we write it as a by b form, where b is not equal to 0 and a and b are co-prime numbers. Okay, next we'll bring this b this side, okay, to the left hand side. So it would be root 5b is equal to a, and then I'll square both the sides. So it will be 5b square is equal to a square. In bracket I'll write squaring both the sides. Okay, next we know the theorem that of irrational number, theorem 1.2 in your textbook, that if any prime number is divided, like any prime number in the say p, any prime number is p. So here you have a prime number 5. When we divide a square by 5, it is equal to we dividing a by 5. Okay, so here I'll write the theorem. Okay, theorem 1.2 in your textbook, you'll just write it, and we'll say that 5 divides a square, hence 5 divides a. Okay, so by this, when we know that it divides a, we'll just write it as let a is equal to 5c, or okay, let a is equal to 5c, because when we know this number divides, we'll write this number and give another variable here. Then what we'll do is substitute this here in this formula. 5b square is equal to a square. So I'll just write it here. I'll write 5b square is equal to, when we do the a square is equal to 25c square, correct? Now this 5 will get common out, cancel, and will be 5 this side. So b square is equal to 5c square, right? So now what I'll do is, now same theorem, I'll just write it here. The theorem 1.2, I'll just write completely, and I'll write 5 divides, what happened here? So I'll write 5 divides b square, hence 5 divides b, correct? Now here we wrote above that a and b are co-prime number. Co-prime numbers are those numbers which don't have any factor except number 1. Okay, the common factor between those two numbers is only 1. For example, I can take 13, 23. Okay, 4, 9, they don't have any common number except 1 as their factor, correct? So here, similarly, I just write that therefore a, so I'll write therefore a and b have at least 5 as their common factor. This contradiction has arisen due to incorrect assumption. Okay, so hence we'll write hence root 5 is an irrational number. Okay, easy. I hope you understood. You can take time to write. No doubts, right? See, this part you have to mug up in your examination. The writing, the way they have told that let us assume to the contrary that this number is an irrational number. Then you have to write the whole theorem. Here I've just written theorem 1.2. You have to write the whole theorem. Okay. And then you have to, your conclusion should also be the same. Okay. So like therefore A and B have at least this number as a common factor. Here we had root 5. So here we have written 5 as a common factor. Okay, but you might have other numbers too, like root 2, root 3. You have to prove them. Okay, easy. So let's go to the next question. Show that 3 plus root 5 is a irrational number. Okay, so let's write the answer for this question. So we'll just write the same thing as we wrote in the previous question. So we'll write, let us assume 3 plus root 5 is a rational number. Okay, then what we'll do is we'll write 3 plus root 5 is equal to a by b. And same thing we'll write in the bracket where b is not equal to 0 and a comma b are co-prime numbers. Okay, fine. Now what we'll do, we'll write the root 5 in one side and take 3 the other side. That is taking the 3 to the right hand side. So it would be root 5 is equal to a by b minus 3. Okay, the denominators are in same, so we'll make the denominator same. Root 5 is equal to a minus 3b by b. Okay, you got it? Now you can write, since 3 comma a comma b are integers, a minus 3b by b is rational number. Therefore, root 5 is a rational number. Okay, but this contradicts to the fact that root 5 is an irrational number. Hence we conclude root 5 plus 3 is an irrational number. Hence we conclude that root 5 plus 3 is an irrational number. Okay. Here, you don't have to prove that root 5 is a irrational number as we did in the first question. Whenever you get a question like this, like you're adding any number or you're multiplying any number with the root 5, you don't need to root 5 or any other just number, okay, any irrational number. You don't have to prove that that irrational number is an irrational number. You can just directly like that we know that this number is irrational number. But when you have any number in specific, like just root 5, root 2, root 7, that you have to prove it as an irrational number, then you have to do that first question method. Okay, simple. Now third question. Prove that the following are irrational numbers. Okay, the first subdivision 1 by root 2. So here also I'll just write as we wrote in the question. We'll just do it similarly as we did above. So we'll just write like, I'm just directly writing. Okay, you have to write that let us assume that this number is an irrational number and you'll write 1 by root 2 is equal to a by b, where b is not equal to 0 and a comma b are co-prime numbers. Okay, so you have to write those things. Then this 2 will go, I'll bring this root 2 in the numerator, so it will be root 2 is equal to b by a. Then I'll write in the bottom, like, I know that since b and a, since b comma a are integers, as we did above, we're just writing it similarly. So b by a is a rational number, and then I'll just write like root 2 is also a rational number, but this contradicts. Then below I'll write that this contradicts to the fact that it's not possible that root 2 is a rational number, root 2 is an irrational number. So hence I'll conclude, hence 1 by root 2 is a irrational number. Simple. Understood? Any doubts? Okay. Next question. 7 root 5. Similarly, same thing again. So I'll just write 7 root 5 is equal to a by b, where root 5 is equal to a by 7b. Then we'll write, since a comma b, 7 comma b are integers, so a by 7b is an rational number. So root 5 is also be a rational number, but this contradicts the fact that root 5 is a irrational number. Hence we conclude 7 root 5 is an irrational number. Understood? Any doubts? Now 6 plus root 2. Same thing, exactly same as the second question. 6 plus root 2 is equal to a by b. Root 2 is equal to a minus 6. A by b minus 6. Root 2 is equal to a minus 6b divided by b, making the denominator same. And then since a comma 6 comma b are integers, a minus 6b by b is rational, therefore root 2 is also rational. But this contradicts the fact that we know root 2 is a irrational number. Hence we conclude that hence we conclude that 6 plus root 2 is an irrational number. Understood? Any doubts? Thank you so much. Please like, share, and subscribe to my YouTube channel.